Hi students, today we are going to start a new lesson from 10th standard, that is your science subject, unit number 8, periodic classification of elements. Okay. As the name suggests, see, it is the classification of elements, right. Let us study each term one by one, right. You know, what element is. I do not wish to go deeper into the concept element, because you might have known what element is, right, and you might have known the names of most of the elements, right. Hydrogen, helium, nitrogen, oxygen, lithium, sodium, potassium, rubidium, cesium, right. Then see here fluorine, chlorine, bromine, iodine, chromium, manganese, magnesium. See here, see at present 118 elements are known, right. But see here, it is not at all easy to study all these 118 elements by a human being in his lifetime. See here, 118 elements, that means n number of compounds, n number of properties and their uses. It is not at all possible for a human being to study all these elements in his lifetime. Then what to do then? See, if we categorize these elements into some groups, then it will make much more better to make them to study, right. So in this topic we are going to study that means the learning objectives are what is modern periodic table and the features of groups and periods, then the trends in the periodic properties, difference between ores and minerals, see here, and the separation, that means the concentration of ores and the metallurgy of some metals that are, say, we are going to study about these things, right. See here, actually scientists, they have been pioneering the properties and the uses and the compounds of all these metals and the elements for the last few centuries. Okay. The classifications were made by many scientists. But many of them went futile, many of them went failure. But at last, Henry Moseley in the year 1912, he made an attempt and he made the modern periodic table. Okay. Now anyway, see, we just look into the attempts made by some scientists, right. For example, D'Aubernay's triads. Triad means it is a group containing 3 elements. He made such an attempt, that means he tried to arrange the elements in triads into the groups of 3 elements, but he failed because he couldn't classify all the elements known at that time. After that, Newland's law of octaves, he also made an attempt, but it also went failure. See, the concept of his study was every 8th element shows the properties similar to that of the first element, like in your musical note, sa, di, ga, ma, pa, da, ni, sa. Sa, it comes after the first note, right. Same way he tried to make the arrangements, but that was also a failure attempt, because after calcium he couldn't arrange the elements in that way. After that, Mendeleev, you know, see, he was a great scientist, Dmitry Mendeleev. He made the classification, but his classification was based on atomic mass, but there were many discrepancies. That was also a failure, because see, since his attempt was based on atomic mass, he was not able to place the isotopes. And see here, atomic mass, for example, argon, the atomic mass of argon is 39.9, but the atomic mass of potassium is 39.1. You just imagine, if his arrangement is based on the increasing order of atomic mass, the one with the less atomic mass should come first. Potassium, the atomic mass is 39.1, but for argon it is 39.95. So potassium should take the place of argon and argon should come in the place of potassium. You just imagine, argon, it is an element that comes under inert gases. It is a gas, it is inactive, but no scientist could suggest argon in a group where lithium and sodium comes. See here, lithium and sodium, these are the elements, see, these are the highly active metals and these are solids too, but here argon, it is a gas and it is a gas, right. So these type of discrepancies made his attempt failure on. Finally, in the year 1912, Henry Moseley, he came forward and he made a new periodic table. This is known as what? Modern periodic table, and his arrangement, his classification, that was based on atomic number. My dear good students, you all know what atomic number is. What is atomic number? It is the number of protons or the number of electrons in a neutral atom, right? He made an arrangement based on atomic number. Increasing order of, he arranged the elements in the increasing order of atomic number, right? So that is modern periodic law. And see, my dear students, this is an important question. State modern periodic law. The physical and chemical properties of all the elements or the periodic function of their atomic numbers. This is modern periodic law. See here, please keep it in your mind. The physical and chemical properties of all elements are the periodic function of their atomic numbers, right? See here, so based on this he made the modern periodic table. What is modern periodic table? It is the tabular arrangement of elements. See here, modern periodic table means it gives you the idea about the classification of elements, but see here, it gives you a vivid idea. That means it is the tabular arrangement of elements, highlighting its repetition of properties. That means the elements are arranged in rows and columns. You can see rows and columns, right? You can see here, you can see the rows and columns here, right? These are arranged in rows and columns and based on their atomic numbers and highlights its repetition of properties, right? See here, now we are going to learn the features of the period. See here, in the modern periodic table, you can see 7 periods. Number 1, first period, it contains only 2 elements. It is the shortest period. Number 1, first period, it contains 2 elements and it is the shortest period, right? Atomic number 1 and 2, hydrogen and helium. Then the second period, it contains 8 elements. Atomic number 3 to 10, lithium to neon. Then the third one, atomic number 11 to 18, sodium to argon. Fourth one, atomic number 19 to 36, it contains 18 elements, potassium to krypton. Fifth one, atomic number 37 to 54, it also contains 18 elements, potassium to krypton. Sixth one, 55 to 86, cesium to radon. And the final one, it is the 7th period, starts from 87 to 118. See here, in a nutshell, what I am trying to say is the shortest period is the first one, it contains only 2 elements, and the longest is 6th one, it contains 32 elements, right? Once again, in the first you have 2 elements, in the second and third you have 8 elements each, 4th and 5th you have 18 elements each, and the 6th and 7th you have 32 elements each, right? So among these, the shortest is the first and the longest is the 6th one, right? Then the features of groups. See here, there are 18 groups in the periodic table. Based on the common characteristics, each group can be, that means it can be categorized into different families, right? Number 1, the first group, that is alkali metals, and the second group, that is alkaline earth metals. Then group number 3 to 12, see, it's a block, see, it is D block elements or transition elements, right? Then see here, the 13th group, that is the boron family, because boron is the head of that family and that family is known as boron family. Then 14th one is the carbon family, 15th one, that is the nitrogen family, 16th, that is oxygen, that is otherwise known as chalcogen family, 17th one, that is the halogen family, it starts from fluorine, chlorine, bromine, iodine and acetylene, right? And the last one, 18th, is the noble gas or the inert gas, that is otherwise known as zero group elements, right? So these are the families. Now next, see here, see, you take whatever group you can take, the outermost electronic configuration, that means the outermost electron number is same for all the elements in the same group. That means the valence is same for all elements in a group, right? The electronic configuration is same. See here, since the outermost electrons are same in all the elements, these elements will show similar chemical properties, and the physical properties, there is a gradation in the physical properties, right? See here, the final one, that means the 18th one, it is otherwise known as what? Zero group elements. That means these are having the stable electronic configuration. So these are what? The features of groups, right? Already I have said, we are studying periodic classification of elements based on the periodicity. What is periodicity? Periodicity means, see, you look carefully into your periodic table. The elements in the same group, it shows similar properties, and in the physical properties they show the gradation in their physical properties, right? What is periodicity? That means there is a repetition of properties. There is a repetition of properties in the periodic table. That is known as periodicity, right? Now we can look into some periodic properties: atomic radius, ionic radius, ionization energy, electronegativity, and electron affinity, right? Okay, see here, what is atomic radius? So you just imagine an atom, right? Just imagine an atom. At the center there is a nucleus. Okay, then see the distance between the center of the nucleus to the outermost electron cloud. That means center of the nucleus to the outermost orbit contain the electron cloud. That is atomic radius. Can you understand, my dear good students? See here, there is an atom. At the center there is a nucleus. Then see, from the center of the nucleus to the outermost orbit that contains the electron cloud, that distance is called what? Atomic radius. Okay, and this atomic radius, that is otherwise known as metallic radius or covalent radius, right? See here, if the bonding is if the bonding is metallic in nature, that radius is known as metallic radius, and if it is other than metal, that is known as what? Covalent radius. Okay, see here, atom is too small to study. Then you just imagine the atomic radius. It is not at all possible to study or determine the atomic radius. Okay, now you imagine there are two atoms. Okay, they just contact with each other. See here an atom and here another atom. These two are in contact with each other. Now the distance between the center of these two nuclei, right? This atom and this atom, at the center there are nuclei. Then the distance between the center of these two nuclei, right, divided by 2, half the distance between the center of the nuclei, half the distance between the center of the nuclei of these two adjacent atoms, that is atomic radius. Okay, see, now what is the trend in the periodic table? Trend in the periodic table, when you go from left to right, what happens? For example, you take the second period. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, right? The atomic number of lithium is 3. That means in the first orbit it contains 2 electrons, and the outermost it contains 1 electron. 2 plus 1 is 3, right? First orbit it contains 2 electrons, and in the outermost it contains 1 electron, right? Now move from lithium to neon. Lithium, beryllium. The atomic number of beryllium is 4. Then it is boron, carbon, nitrogen, oxygen, fluorine, and neon, right? So the electrons are added to the same orbit. In the second orbit, see, in the case of lithium, there is 1 electron in the second orbit, but in the case of beryllium, there are 2 electrons. So when you move from left to right, in each step you are adding 1 more electron, right? 1 electrons each. That means you are adding the electrons to the same orbit. When you add 1 electron, there is an increase in number of protons in the nucleus. So nuclear attraction increases, right? So when you move from left to right, what happens? The attraction increases and the size of the atom decreases, right? So this is a trend. When you move from left to right, the atomic radius decreases, since the electrons are added to the same orbit. But in the case of group, when you move from top to bottom along the group, in the group, For example, in the first group, lithium, sodium, potassium, rubidium, cesium, francium, right. So, when you move from top to bottom, that means from one element to the other, what happens? An extra orbit is introduced there. In the lithium, you have only 2 orbits, 2 electrons, 1 electron, 2 plus 1 is 3, but in sodium, 2 plus 8 plus 1, 2 plus 8 plus 1, that means inner side you have 2 orbits and the outermost one there are 3. Okay. So, this is repeated. So, as the orbits are introduced, the size increases. So, this is, so what I am going to conclude here is that the trending of atomic radius is when you move from left to right it decreases, and when you move from top to bottom along the group it increases, right. Okay. See here, the next one is ionic radii. You know what ion is? Atom is neutral, but ion, what is ion? Ion is the charged particle, right. Ion is the charged particle, may be positive or negative, may be positive or negative, right. When you add an electron, it becomes negatively charged particle. When you take electron from a neutral atom, it becomes what? Positively charged particle, right. Positively charged particle means it is cation. When you take an electron from a neutral atom, it becomes positively charged, that means it is cation, and when you add electron to a neutral atom, it becomes what? Negatively charged ion or anion. See, similar to the case of atomic radius, here also ionic radius. What is ionic radii? It is the distance between the center of the nuclei and the outermost orbit contain electron cloud, okay. Or otherwise we can say it is a distance from the center of nucleus to the point where it exerts its influence on the electron cloud, right. That means simply distance between the center of the nuclei and the outermost orbit contain electron cloud of an ion is called ionic radius, okay. What is the trend here? In the modern periodic table, the ionic radii also goes on decreasing when you move from left to right. The reason is same, because the nuclear attraction increases and the atomic size decreases, okay. So, that is why the ionic radii decreases, and along the group from top to bottom the ionic radii increases because of the introduction of new orbits there. The next one is ionization energy. See, as the name suggests, ionization energy. What is ionization? You convert a neutral atom into an ion, right. You convert a neutral atom into ion, that is ionization. See, you imagine a neutral atom, some number of protons are there in the nucleus and the same number of electrons are revolving around the nucleus, right. So, this nucleus attracts this much of electrons towards its side. Always it has an attraction, nuclear attraction. Nucleus attracts this electron. The charge of nucleus is positive, you know, and the charge of electron, that is negative. There is always an electrostatic force of attraction between oppositely charged particles. Here the nucleus attracts the electrons towards its side. When you try to remove an electron, what happens? You must invest some amount of energy, otherwise you can't, right. So, in order to remove an electron from a neutral atom, since this is attracted by the nucleus, it is not at all easy to remove that electron. You have to spend, you have to invest, you have to put some amount of energy to take the electrons from the neutral atom, right. That much amount of energy, that is known as ionization energy. That means the minimum amount of energy required to remove an electron from a neutral atom in its ground state, that is known as ionization energy, right. See, this is an energy. So, this is measured, the unit, that means this is measured in terms of kilojoule per mole. Now, the trend, what is the trend? You know, see, when you move from left to right in a period, the atomic size decreases and the nuclear attraction increases. That means you have to apply more and more amount of energy to remove the electron and moving from left to right. That means ionization energy increases along the period, and in the group ionization energy decreases, right. See here, the next one is electron affinity. Electron affinity means here you convert the neutral atom into anion, that means you have to add electron to your neutral atom. Here also, see here, when you add electron to a neutral atom, some amount of energy will be released, just opposite that of the ionization energy. Here, when you add an electron to a neutral atom, what happens? Some amount of energy will be released. That energy is known as electron affinity, right? Since this is also an energy, this is also expressed in terms of kilojoule per mole. Okay. See here, the last and final periodic property is electronegativity. What is electronegativity? See here, you imagine a molecule hydrogen chloride, right? Hydrogen and chloride. Okay. The atomic number of hydrogen is 1, that means it has 1 electron in its outermost orbit. Chlorine, its atomic number is 17, in the outermost it has 7 electrons. But in order to make the bond between these two atoms, what happens? Chlorine is in need of 1 electron, because in the outermost it has 7 electrons, it is in need of 1 electron, and hydrogen, it has 1 electron, it is also in the same condition, it is also in need of 1 electron. So, both the atoms are not in a condition to give its electron to any other atom, right? But these are in a similar condition of getting an electron. Now, this hydrogen and the chlorine, they share 1 electron each. That means there is a bonding because of the sharing of the electrons between these two atoms, right? So, a paired electron is there, hydrogen, then a pair of electron, that means one from hydrogen and another from chlorine, there is a pair, right? Pair. There is a covalent, that bonding is known as covalent bonding. But when you compare hydrogen and chlorine, the attractive power, that means the electron withdrawing power of chlorine is much more greater than hydrogen. So, what happens is, here chlorine attracts that shared pair of electron towards that side, right? So, when it breaks, what happens? Chlorine, it moves with 2 electrons, that means that shared pair of electrons, and it has negative charge. Hydrogen, it has positive charge. That means here the relative tendency, the tendency of the chlorine to attract the electron is more than hydrogen, right? Now, I am going, so that means the definition goes like this. Electronegativity means it is the relative tendency of atom in a molecule to attract the shared pair of electron towards its side. Electronegativity, see here, see it depends upon different properties like what, bond energy, ionization energy, and electron affinity and what not, right? See here, the electronegativity that can be determined based on Pauling scale, that is, it is widely accepted scale to measure the electronegativity. See, some of the values of the electronegativities of the elements are given in your textbook, and for fluorine it is 4, for chlorine it is 3, and for bromine it is 2.8, and iodine 2.5, hydrogen 2.1, and for sodium it is 1, right? See here, if the difference in electronegativities between two atoms is 1.7, then it is understood that the bonding is 50% ionic and 50% covalent, right? If it is less than 1.7, it means the bonding is covalent, predominantly it is covalent, and if it is greater than 1.7, the bonding is predominantly ionic, right? Okay, dear students, it's evaluation time. See here, let us look one by one. What is atomic radius, right? Again, what is atomic radius? It is the distance from the center of the nucleus to the outermost orbit containing electron cloud, right? When you ask this question, see here, you have to understand the trending also, right? So, you know, when you move from left to right, since the electrons are added to the same orbit, what happens? The atomic size decreases and the nuclear attraction increases, right? So, the atomic radius goes on decreasing when you move from left to right. This is the trending. Along the group, what happens? Since the new orbits are being added, the size increases, that means the nuclear attraction decreases and the size increases. So, that is the trending, right? So, atomic radius decreases along the period and increases along the group. Next is, what is ionic radius? Already you know what ion is. Ion means it is a charged particle, may be positive or negative, right? So, if you take an electron or if you add an electron, it becomes ion. Always remember, cation, positive charged ion is cation. The size of cation is always smaller than neutral atom. Why? Because more number of protons attract less number of electrons here, cation. Reverse is applicable in the case of anion. See, in the case of anion, you are having more number of electrons but less number of protons. This less amount of protons attract more amount of negative charge. That means attractive power is less compared to the neutral atom. So, the anion, size of anion is always much higher than the neutral atom, right. The next thing is what? Electronegativity, you know. Electronegativity, it is a tendency, okay. So, when two atoms are in a molecule, one is having much more attractive power of on the shared pair of electron than the other. So, this much the attractive power of an atom in a molecule to attract the shared pair of electron towards its side, that is known as electronegativity. And see here, electronegativity also increases when you move from left to right, and it decreases when you go on from top to bottom along the group, right. Then ionization energy, you know ionization energy, it is the minimum amount of energy required to remove an electron. Since the electrons are attracted by the nuclear power, the nuclear attraction, it is not at all easy to remove that electron. That means you have to supply some amount of energy so that you can remove that electron. So, that minimum amount of energy, that is known as ionization energy, okay. This is expressed in kilojoule per mole. The last one is the electron affinity. What is electron affinity? It is the amount of energy released when you add an electron to a neutral atom, okay. So, this is also expressed in kilojoule per mole. Now, finally the trending is along the group atomic radius decreases, ionic radius decreases, electronegativity increases, ionization energy increases, and the electron affinity also increases. But in group atomic radius, it increases, ionic radius increases, electronegativity it decreases, and ionization energy decreases, and the electron affinity also decreases, okay. So, I would like to wrap up here, students. Thank you very much.